Hello, this is Paul from Professor Tech. In this video, let's prove the Theorem 3.5.4, the second part, geometric meaning of 3 by 3 determinants. And the theorem gives us the absolute value of the determinant of 3 by 3 matrix is equal to the volume of the parallel nanopipe, okay, which is here, and this box equal to the value of this box. And what this box means, and the U, V, and the W, these three vectors is just the first, the second, and the third row of the matrix. You see, and the result is quite interesting, right? Therefore, we know the meaning of 3 by 3 determinant is just the value of this parallel pipe. Let's prove it. So how to prove it? So we do have two cases. The first, if these three vectors, okay, probably form or fall into the same plane, and the second case is not in the same plane, therefore we form a parallel pipe, right? So let's do in two cases. Let's prove the case 1 is U, V, and W. Okay, so case 1 is vector U, vector V, and vector W. For, or let me say, it's a line in the same plane. What does it mean? So whatever, okay, so for example, if V and the W form, okay, is non-collinear, therefore V and the W form a plane, and then another vector U falls in the same plane. So therefore, that we learned this before, right? In this case, what do we have? We can calculate it. Okay, so what's the determinant in this way? See, this case is determinant of the matrix. Let me say determinant of this matrix. Let me say the matrix is A. Okay, so this is the determinant of the matrix A. Therefore, we can calculate determinant of the matrix A equals 0. Why? Because definitely unknown. So because U fall into the plane of V and W, therefore U is a linear combination of W and V, right? A linear combination means the first row of this determinant should be a linear combination of the second row and the third row. Therefore, by the third type of row operation, we can make the first row all 0. Therefore, the determinant is 0. All right. Okay. And again, I also know the volume. Let me simply say the volume of this parallel pipe is also 0. Why? Because no parallel pipe formed, therefore the value is 0. Therefore, the first case is true. What's the determinant? The absolute value determinant equals the value. Yeah, that's good. So the first case, our result is true. Okay, so now we look at the second case. Case 2. Case 2, which means U, V, and W do not lie in the same plane. Okay, if they're not in the same plane, therefore we can form this parallel pipe. Okay, so let's see. Now I can calculate the volume. I can work on the volume first. In this way, what's the volume? So the volume should be this is a regular solid, right? So I can calculate should be the area of the border. Okay, so you simply say here. Okay, the area of the base, right? And then comes the height. So the value should be the area of the base. What's the base? The base is a parallelogram. So therefore, is the area of a parallelogram, and then times. Okay, let me change. This is a number. Just the times the height. I don't know where the height. I think we can make it height. So let's look at the base first. The base is the area of a parallelogram. The first theorem we know is the norm of what? It's the norm of the cross product of V and W, right? Yeah, see. So the area first I easily get. So the area, let me put here a little small, which is the norm of V cross W. No problem, right? So this is from the theorem. This is from the first theorem 3.5.4. Okay, you can check. And then let's look at it. Check the height. Oh, what is the height? We need a little more knowledge. Okay, so the height. So first we need to draw this line. Okay, draw a straight line perpendicular, orthogonal to the base. Okay, which is like this way. I draw. See, this is a perpendicular to the base. So what is this vector? We definitely have a knowledge of this. This is what? This is V cross W. Okay, V cross W. See, we use the right hand, the rule of the right hand, and the V is this way, and then W, and then I know the directions, they are point up. Good. So this is the direction perpendicular to the base, and we have the height. So the height at this time I can project this vector, okay, onto the direction of V cross W. Can you see? Is that okay? So therefore, I definitely find that the height. So if I say the height is this 2 here. Okay, this is the height. So I say from here to here. This is the height. Okay, so the height exactly is the projection, right? The norm of the projection. Sorry, is the norm of the projection of U onto the direction of V cross W. Yeah, definitely. So we find the height. So let me copy the height here. So the height is the norm of the projection of U onto the direction of V cross W. Yeah, almost. Okay. Now we need to just do calculation. So let's do calculation. So this equals first V cross W. Let's put here. What the projection? Okay. We learned the projection before, right? So I directly put. So the projection should be U dot the dot product U dot V cross W, then over the norm of V cross W. This is the direction square. So this is the coefficient, and then the direction is V cross W. Let me put a parenthesis. Okay, makes sense, right? So here is from the previous result we already have. Now I simplify. See, and this is the coefficient Okay, this coefficient I can take out the side, and then I put the absolute value. Okay, so what do we left here, and here is just reach the second power almost. So what do we have? We have the first v cross w. Let me just leave it here, and then times absolute value of u dot v cross w. This is absolute value, and then over v cross w, the norm squared, and we left the 1, okay, times the norm of v cross w, and then we simplify, see, and this is the second power, and then the denominator also the second power, so we cancel everything. We have 1 left, okay, which is the absolute. Let me change. This is just the absolute value, okay. In case you thought that's a determinant, no, this is the absolute value. Absolute value, let's use this of u dot v cross w. Okay, so what it is, and we learned this before. This is a triple product, but there's a scalar triple, right? This is scalar triple product. We do have a way to calculate it. To calculate it, the easiest way is use the 3x3 determinant. Use the first row, v is the second row, w is the third row. Remember that. So therefore, by the definition or the method to calculation is the absolute value of determinant u, which is u1, u2, u3. V is v1, v2, v3, and the w, the third row, which is w1, w2, and w3 is determined. Can you see? Is this the result? Okay, so we can just go back. See, we finally proved the second case is also true. The volume of the parallel pipe is equal to the absolute value of the determinant. Yeah, that's all. Thank you.